Assalamu alaikum. My name is Yawar Khalid. I am a student of the fourth and final semester of IBA MS Data Science program. Today I'll be demonstrating a product that I have developed as part of the MS Data Science capstone project. My supervisor for this project has been Dr. Tariq Mahmood. I'll begin by introducing the product itself. I have developed a one-stop time series forecasting solution to facilitate multiple different organizations and data teams in determining the best performing and the most accurate model for forecasting their future time series data using their past historical data. The web app itself works with all univariate time series datasets, including customer data, including market data, stock price data, customer engagement data, or even stock price data. Our web app runs multiple forecasting models and provides the mean absolute percentage error accuracy for all of the models to determine the best performing one for our particular data set. So it is customizable to every data set. For the purpose of versatility, I have also included the provision for the user to run every model separately rather than all at once. Then the user can compare all the models. Our app also has provision for downsampling the datasets and smoothing the time series and differencing the time series and removing seasonality to aid in better predictions. I have, as a secondary product, or as you can say a byproduct of this web app, I have also developed a Python package with the same functionality at this, but it can be used to execute this itself, but it is for more experienced coders or more experienced programmers who can understand that and who can also tune that as per their requirement. So let's begin with the demonstration. So this is the time series. The web app itself has been built with Streamlit. Streamlit is a Python package that helps build web apps. So let's begin by the demonstration. First of all, we select our data set from the given data sets. We can also add more data sets as we like in the repository of this folder and then select that as well. For our demonstration, we'll be selecting the ads data set. The ads data set itself has hourly data for the number of ads that were run at particular times for 7 days. First, we'll select the file, then we'll select the column that we want to predict. In our case, the number of ads, our data only has two columns, two features. Our ads will be our predict column, and our date column would be the time. So once we select that, our time series will automatically our time series and our data preview will automatically uh, be plotted. And then we'll get an option if we want to resample our data set. In our case, we honestly do not need resampling. However, if we want to resample the data set, we can. I'll just demonstrate it to you. In case I want to resample it, I'll just go to yes, and then I'll select the order to which I want to resample. It's already hourly data, so let's resample it to daily data, even though that doesn't make sense. And we'll select our aggregate. In our case, we'll be selecting sum since it's the count of the ads that are run. So this data set is resampled, and then we can forecast based on that. However, we do not need that for this data set. So we'll go on to the next step after proceeding with no. So now we'll begin forecasting, and we have multiple options to do that. The first thing that we will do is input our season size. Normally, season size would be, for example, for hourly data set, if we have 24 hours data, then our season size is normally 24. If we have monthly data, then our season size would be 12, since each year has 12 months. If it is daily data, then our season size would usually be 30. So accordingly, our data set over here has 24 observations per season. So we'll select that, and then we'll start selecting a model. We have options for approximately 8 models in this. Hold winter method is one, Serima is other. The machine learning models has I think 4 different models, including linear regression and XGBoost and multiple variations of that. And then finally, we have LSTM. We have the option to run each model individually, or we have the option to run all models separately and compare the performance. So we'll be running them individually, and I'll be demonstrating that to you. So firstly, we will begin by the hold winter method. This is very simple. I have input a button over it. All you have to do is you have to forecast with hold winter. This is going to use the backend coding, and it is going to plot a moving average that was calculated for them, and it will output a output the model against the data set, and it will also predict for future 50 data sets. Our model in this case, our data set, got an accuracy with the whole winter method, that is triple exponential smoothing, of 5.02% of mean absolute percentage error. We will then move on with to the second, Sarima. Sarima is very interesting actually. It takes a little bit of time to run, so the video may be long. So what it does is, firstly, as soon as we select this option, our series is initially our time series is initially automatically differenced. How is it automatically different? It's different based on the AD Fuller test. The AD Fuller test is run in the background, and if the requirements of the AD Fuller test are not met for the time series to be stationary, then it differences until it is stationary. So at this point in time, the time series is already stationary. That is, it has already passed the AD Fuller test. So now we have the option. Once we have this, we have the option. We our PACF and ACF plots are already plotted, and now we have the option to see and observe and see if our dataset has seasonality still in it. If it does, then we will difference for seasonality. If we select the option yes, we can see there is seasonality in the dataset already. So if we can see there's seasonality, so we will select yes. Once we have selected yes, it has differenced the time series for uh, seasonality by a span of 24, since our season is 24, and it has plotted the new PACF and ACF plot. Now we will observe again and see if there is seasonality. Now in this process, it will now start differencing by one more lag rather than 24 more lags, because to get rid of the seasonality. So once we select yes, we will see that the seasonality doesn't exist anymore. Now we will only say no, and we will move on to the next step of our Sarima autoregression model. So now the computationally heavy part. So for determining the PQDS parameters, we are using a Sarima optimizer that takes a range of values and finalizes the best performing parameter values for your Sarima model. I think it is called Auto PM Darima or something like that. I can't recall completely right now. But so our program outputs a guidance for selecting each of our uh, parameters. So P, Q, D, S, P, Q, and D are all provided over here. This is how you select them, and this is where you input your ranges. So let's go through the first P. So it mentions here that to determine the initial P, you need to look at the PACF plot above, that is a partial autocorrelation plot above, and find the biggest significant difference lag, after which most other lags become insignificant. So in our case, we have 1, 2, 3, 4. So we can see that our P value should be around 4. So we will see this, and we will go there, and we will input a starting and ending range for P. So it could be 4, it could be 3, or it could be 5, because we only plotted 2 or maybe 3 seasons over here, not more than that. 24, 48, yeah, not more than 3 seasons. So maybe after the third significant lag, it would go on further. So we will technically input 3 and 5 range over here, but since we are short on time in this, and the higher the ranges, the higher the time it would take to train. So we will not do that right now. For our D, for our S in this parameter, our S is the season that we've already mentioned before. Our D is order of integration. This is simply the number of non-seasonal differences. In our case, our model has already differenced based on the idea before, and if the season has if the time series has already been difference, then this is already input as 1 automatically, because the small d is basically tells if your time series has been seasoned for seasonality, and the big D over here tells if it is it has been difference for seasonality. That is, the first one is for stationary. So this is automatically taken from the above step. So we're just gonna leave it as it is, 0202. We'll get a lower accuracy, but since we shorten time, we're not gonna do that, and we'll click on this, and our time series should be plotted in a few seconds once the auto parameter tuning is done. So we'll wait a few. It's already done. Okay. So our model summary is outputted over here. These are the parameters that it took for P, D, Q, S, all of them. Our S is over here 24, and the rest of them, the parameters are over here. Over here, these parameters are only tested for within these ranges of 0 to 02 in our case. And after that, as before, the forecast is plotted, the model versus actual is plotted, and a future forecast of 50 timestamps is already given, and we get a mean absolute percentage error of 4.58 in this percent in this particular example, and this is also output in this. So we are done with the Serima. Then we'll go to our third, my third model, which are the multiple machine learning models. So this is basically based on feature engineering. We lag our data set from a particular timestamp to a particular timestamp. Our lagging should be based on multiple factors that are mentioned over here. So we have to take into consideration multiple factors before we start lagging our time series. Since we are using machine learning model, we'll obviously need more than one feature. So we will create features by lags. So in our first, let's go for 6 lags to 24 lags. So we'll put in 25 over here, and we'll just forecast our model, and then we'll go through the outputs. Okay, so this was quick. So our data set has been lagged from 6th time series, 6 timestamp to the 24th timestamp. So we have multiple features now. The first model that we do is simple machine learning model of linear regression forecasting. Since we have multiple models, we use all these lags as features, and we train our data set over multiple features. Our second is based on further feature engineering. We get multiple features from our from our datetime column, as in hours, weeks, if it is a weekday. So these are the things that we can get from our dataset, and we further increase our features in our dataset. And based on this, we again run linear regression, and now we get an improved MAPE of, previously we had 5.86, and now we have 5.45. Now this can obviously, since there are so many features, this can obviously sometimes result in overfitting. For that purpose, ridge regularization or ridge regression can be used to avoid overfitting. So we have gone through with that. We have applied simple L1 ridge regression regularization, basically a regularization algorithm that is used to avoid overestimation in this. And we have used ridge regression to forecast our data set. However, our ridge regression in this particular case has decreased our accuracy, our MAPE percentage. It is better than linear regression by marginally, and it is worse than linear regression with feature engineering. So we go with ridge, and then we go with lasso regression. Similarly, for the same purpose, lasso seems to perform better over here. And then finally, the messiah of machine learning models, the extreme gradient boosting or XGBoost, we run on the same data set with all the lag and with all the features that we've added. We run the XGBoost forecasting. We run the XGBoost ML model to forecast our data set, and we plot model versus actual, and we see our MAPE percentage over here is the best out of all. So that is, and these are all output in the data frame in the end. So these are all the mean absolute percentage errors. Okay, so that were the 4 or 5 machine learning outputs. Now we go to the big boys, the LSTM model. The LSTM model will obviously, since it's a long short-term memory model, it's a convolutional network-based model. It is going to take a very long time to train. So to run this in our app, it's very simple. However, it will obviously take a very long time to train, uh, given the size of our season and the size of our observations in our data set. So first of all, we will determine the test data set size. In our case, we're going for 0.2. 20% of the data will be used as test data set, and then we will determine and input how many epochs we want to run it over. Normally, to get an adequate result, it could be anywhere between 50 to 60, but for just for the demonstration purposes, I'll be running only two epochs in this case. It is going to take like a couple of minutes, I think, for this, but it will be training my LSTM model and will be outputting my result. So yes, so firstly the loss function is plotted. Since there were only two epochs, then obviously there is a straight line, and the MAPE over here is 30.59 because we only ran two epochs, so we can't really compute over this. But nevertheless, for demonstration purposes, here is the model versus prediction. It's very off in this case, and the data frame is predicted. And the very last thing is, and the very last thing in our uh, web app and our solution is the run all model feature. This will help you run all the models one by one, and once you are done with all the models, I can run it again, but that's going to take a long time. I am not going to run it again. I'm just going to tell you what it does. You're going to run all the models one by one similarly to that, and once you're done with the last LSTM model, you'll get an option to compare. You'll get a button to compare. Once you have all the models, uh, you have ran all the models and you have all the forecast MAPE percentages and accuracy percentages. As you go through the models, your mean absolute percentage error will be outputted over here for easy access. And once you are done with the very last model, you get an option to compare all the models. Once you are done with that, you can press the compare button. You can get visualizations for your MAPE percentages, and you can compare all the MAPE results and finalize the model. So that is it from my side. This is my product. I feel that this has good application in multiple, especially in small and medium enterprises where uh, companies don't actually invest much in data analysis and data forecast. It is a solution that is easy to access as long as you have clean data. So that would be it from my side. Jazakallah. Thank you for your time. Allah Hafiz.